Welcome guys to my YouTube channel. So today we are going to do this question paper. It's a paper that was written in 2018 International IGCSE Physics paper 1. So most of the questions that we're going to do, we'll get them from this paper. If you want me to send you the link of this paper, just leave a comment on the comment section. Please remember to like and subscribe. Good. All right, next question. When the water balloon is dropped, it accelerates. So acceleration, accelerate, this is our keyword that we need to look at. And now it says that what happens to the air resistance, the force, the air resistance acting on the water balloon as the balloon accelerates. Now they want us to find out what happens when these balloons accelerate downwards. We know that it will be accelerating downwards. So okay, let's go and recap back our two. This one is air resistance and this one is the weight. If you did not watch the previous question or the previous video, you can just go and watch the previous video. You'll see how we found these two forces. So now as this balloon accelerates downwards, we know that the resultant force is downwards, since we were able to discuss that in the first question. So as this balloon accelerates downwards, what it means that it means the speed of or the velocity of this balloon will increase, because the change in acceleration over time is what? It's acceleration. So remember, if you accelerate a car, the speed of the car will increase. It means the car will move more faster. So this is the same concept that we're using here. As this balloon accelerates, what will happen? The air resistance will increase. Why the air resistance increases? It is because as this balloon moves more faster, there will be more air particles that will be acting on the balloon as this balloon is moving downwards, as this balloon is accelerating downwards. So therefore there will be more air particles, and these air particles will try to oppose the motion of the balloon, will try to oppose this balloon from moving downwards. So when the question says what happens to the air resistance acting on the balloon as the water balloon increases, the air resistance increases. Air resistance increases. Let's go to the next question. Some quantities are scalars and some are vectors. Complete the sentence. Forces are vector quantities, okay, which is true. This means that they have magnitude, the word magnitude. Also, you can also say size and direction. Just to recap back, vectors, they have both magnitude and direction. Scalar quantities, they only have magnitude, they do not have direction. Right, let's go to the next question, this one. Now it says that add one tick to each row of the table whether each quantity is a scalar or vector. Remember, scalar quantities are quantities that only have magnitude, and vector quantities are quantities that have both magnitude. And another word for magnitude is size. So vector quantities, they have magnitude and direction, or they have size and direction, then you get the full mark. So acceleration, it's a vector quantity. Why acceleration is a vector quantity? Because it has both magnitude and direction. If a car accelerates, they will tell you that the car accelerates 2 meters per second square to the right, meaning that the 2 meters per second square, or the 2 meters per second square, that's the magnitude. The to the right is the direction. So distance, it's a what? It's a scalar. distance is a scalar. Why distance is a scalar? Because if they ask me that how many kilometers to Abu Dhabi, I will tell them that to Abu Dhabi maybe it's like I don't know, I'm just guessing, maybe it's like 100 kilometers. I don't know. It's just a guess. So basically it didn't tell the person the direction. It means you only told that person the distance. So now speed